Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
So let's try to figure out how much product can be made with 15.39 grams of one of our reactants. So if we take a look at our first chemical reaction where we take potassium and chlorine and make potassium chloride. If we start out with 15.39 grams of our chlorine, how much KCl can we make? So the process in each of these is going to wind up being the same. The first is we convert grams to moles. That uses molar mass. Then we're going to use the mole ratio. That's based on the coefficients of our chemical reaction. And then we have to convert back to grams. And that's going to use molar mass of our product. Okay, so let's start out with our 15.39 grams of Cl2. And now to convert to moles, we know that 1 mole of Cl2 has a mass of 70.906 grams. How do I know that? When I go to the periodic table, I find that the mass of one of the Cl2s is 35.453. I've got 2 of them, so I multiply that by 2. That gets us our moles of Cl2, but we want to know about KCl. So we use the mole ratio, what we want to go to, so we want to know about KCl. The coefficient is 2, so for every 2 moles of KCl we want, we use 1 mole of Cl2. And then that final step is we have to get the molar mass of KCl. So we'll look up the mass of K, about 39.1, the Cl, 35.453. We'll add them together, and the molar mass is 74.55 grams per mole. And now if you take a look, grams of Cl2 cancel out, moles of Cl2 cancel out, moles of KCl cancel out. So we're left with our grams of KCl. We do our math to 4 significant figures and get 32.36 grams. That's how much product we're going to make. And we can do that for several other chemical reactions. So if we've got potassium, but instead of reacting with chlorine, we'll react it with bromine to make KBr. Let's start with 15.39 grams of the bromine. So we'll follow the same process. We've got 15.39 grams of Br2. So we're going to have to find the molar mass. We'll go to the periodic table. Each one of those is 79.905. So 2 of them are going to be 159.81 grams. Mole ratio, we want to make KBr. So 2 moles is what we would make of our product. And how much Br2 is needed to do that? 1 mole. And then we'll get the molar mass by taking a K and a Br and adding them together, 119 grams are in 1 mole. And to 4 significant figures, we get 22.92 grams of KBr. In the third case, we're going to take some chromium. We're going to add some oxygen and make chromium 3 oxide. Same process. If we have 15.39 grams of our oxygen, the molar mass of O2 is 32 grams per mole. Okay, we want to go to our product, Cr2O3. So if we want to make 2 moles of Cr2O3, that's going to require 3 moles of oxygen. Then we need the molar mass of Cr2O3, which is 151.99 grams per mole. And we're going to wind up with 48.73 grams. And again, you can always go back and double check that your units cancel, right? Grams of oxygen go away, moles of oxygen divided by moles of oxygen go away, moles of Cr2O3 divided by moles of Cr2O3 go away. And then we just take each of our numbers and multiply them together to get our value. And finally, one more example. We'll take some strontium and some oxygen and make strontium oxide. And we'll start with 15.39 grams of the strontium this time. So the molar mass of strontium is 87.62 grams per mole. We'll convert that into strontium oxide with the mole ratio. 2 moles of strontium oxide over 2 moles of strontium. And then we'll convert that back to grams by using molar mass. 103.62 grams of strontium oxide are in 1 mole of strontium oxide. We can verify one more time that each of our units cancels out. And when we do our math to 4 significant figures, we get 18.20 grams of our product.